All right, let's go and review what we've been talking about recently. If you would also have your books out, open to page 503. Page 503, we've been talking about probability. And I know we're coming off a weekend here, but Audrey, what is probability?
When you have a number of outcomes over number of
Okay, can you give me a better definition, Brandon? What is probability? You know, I had a feeling you weren't going to be able to answer it. I was just like, the odds of him actually getting the definition of probability, the likelihood of that taking place, it's just pretty low. I didn't think he'd get it. Genesis, what's probability? The odds or likelihood of something happening. I'm picking on Brandon. Poor guy. He's like, you didn't pick on Audrey like this. I don't know. You're just more fun to pick on. I really appreciate you, Brandon. Probability, odds of something having the likelihood that something takes place. And Audrey kind of went with the formula here, but what is the formula used to find a probability, Michael?
Possible outcomes.
Well, that's going to be the denominator, the number of possible outcomes.
The number of wanted outcomes.
There we go, the number of desired outcomes, or the number you want. Number you want over the number of possible outcomes. And anyway, we did quite a bit of work with that. Now, some rules for probability that we talked about said probabilities can never be lower class than 0. If something's absolutely impossible, the chances are 0. That's the probability. If something is definitely certain going to happen, class, 1. Probability is 1. So all probabilities that have to lie between 0 and 1. We also said that if you were to take all the different possibilities that could exist and you added up those probabilities in a certain situation, the probabilities have to add up to, Kendall, 1. Must add up to 1. For that reason, then, if we have the probability that something does occur, and I wanted to find the probability that it does not, I would simply subtract from 1. Take 1, or 100% probability, minus the probability that something does happen, and that gives us the probability that that thing does not happen. Do we have a name for the probability of something not happening, Maddie? The probability that Mr. Nadaski does not see the correct answer on your quiz. Help, class? It does start with a C. The complement, or complementary probability. We looked then at what we call compound probabilities, where instead of just a straightforward probability, we looked at a couple of different things being able to occur. And we said that a lot of compound probabilities are joined by the word or. The probability that this happens or this happens. And we said anytime there's an or, there's a main operative word we need to remember, class. Add. And that's what we're working on the homework. When you see an or, we're going to add probabilities together. Now, that assumes that the probability of this is totally different from the probability of this. That these two events, these two outcomes are completely separate from each other. Well, a lot of times that's true. If that's the case, we would describe those two events as being 2 words. Anyone? Mutually exclusive. What is it, class? If one thing happening is totally separate from the other thing happening, we would say those two events are mutually exclusive. The probability of us playing soccer or us playing volleyball, those are mutually exclusive. They are totally separate sports. But if I said, what's the probability we do volleyball, or maybe we do a team sport? Well, volleyball is a team sport, right? I mean, every now and then you get a girl on the court who forgets that, but I mean, it is a team sport, right? So they're not mutually exclusive, and sometimes we'll deal with those as well if events are not mutually exclusive. I think the example I gave was we were talking about different colors of balls that also had numbers on them. Well, you could have a red ball that also had the number 2 on it. That was possible. I would refer to that as the overlap, a situation where one item actually satisfies 2 different possibilities at the same time. And we said if we have overlap, just subtract it away at the end. So or means we add. Class, what does or mean? Add the likelihoods together, add those probabilities. But if they're not mutually exclusive, if there's some overlap between them, just Subtract that excess away. Page 503, in your textbooks, you did numbers 32 to 40. Well, let's see how we did here. It says Marina is checking parking stickers in a parking lot, so maybe she's a security guard. And, campus security kind of thing where, CVCC, CSU, different colleges have, get stickers. And if you got a sticker, you're allowed to park. You don't have a sticker, you're not allowed to park. You have this sticker, you can't park here because it's special people that can park there. That kind of thing. Anyway, 54 vehicles are parked. There are 38 cars, 11 trucks, 4 motorcycles, and a motorhome in a parking lot. All right, so what are the odds that she's checking parking stickers? She checks a motorcycle or a car. Well, what's the likelihood she checks a motorcycle? Brandon? We're doing 32. I'm sorry. 32 through 40 the even. Let me look at 32. 72 books on a bookshelf. We'll get to 31 later. 72 books on a bookshelf. 42 fiction books. 10 dictionaries. 12 encyclopedias. 8 devotional books. What's the odds of a fiction book or a devotional book being chosen? What's the odds of a fiction book, Brandon?
50 out of 72.
Fiction book.
42 out of 72.
42 out of 72. And what are the odds of a devotional book?
10 out of 72.
Devotional book?
8 out of 72.
8 out of 72. And we just add them together. And so we get 50 to 72. There we go. And we would want to reduce all ratios. I'm not into writing these as decimals and things like that like the book is, but I do want to reduce. And I can at least divide what out of top and bottom, Brandon? 2. A 2. So I would get 25 to 36. By the way, if you just type the fraction into your calculator and hit enter, it'll reduce it for you. So we don't have to worry about that. And of course, we're only going to deal with proper fractions. Improper fractions are greater than 1. We won't have any probabilities greater than 1. Now to Brandon's point, he's like, why don't I just add these two together, get my value, and then put it over the 72? And that works just fine as well. For instance, for a fiction book or dictionary, fiction or dictionary book, fiction book or dictionary, well, how many total fiction books and dictionaries put together do we have, Audrey? 52. So we would say unreduced, we have a 52 to 72 chance of picking one of those books if we were blindfolded. Why are we blindfolded? I don't know. We reduce it down. We can actually divide by 4 this time. Divide this by 2. Anyone? 18. 13 to 18. Of course, you can plug that into the calculator if you wanted to. Fiction, book, encyclopedia, or devotional book being chosen. Well, how many total outcomes make us happy here, Abby?
62.
Basically, anything except a dictionary makes us happy. And 62 out of 72, we reduce it down, we get
31 over 36.
31 to 36 chance. Good questions on that. Again, it says round to 3 decimal places. I don't normally do it. Get your calculator out, though. If I did 31 to 36, it's 31 divided by 36 on the calculator. I would normally then use those 3 decimal places to get a percent chance. What is the 3 decimal place answer here, Genesis? 0.861 or 86.1%. Remember that if you wanted to make a number into a percent, just move the decimal back those 2 places. So there's an 86.1% chance. Decimals on their own very rarely used in probabilities outside of math textbooks. So real life, you're going to use ratios or you're going to use percents. Questions on number 32? Yes, sir.
My calculator doesn't give me decimals when I do that. So will it be a online test or quiz?
Probably not, but let me, yeah, because that's right, it's only doing the other. There we go. All right, you should still be able to type in fractions as normal, though. That'll just keep you from only getting fractions when you divide. All right, let's take a look at number 34. I like this problem better. Go ahead and read it for us, if you would, Maddie.
Jason bought a box of 4 donuts. The box contained 2 donuts with strawberry filling, 2 donuts with blueberry filling, 1 donut with chocolate filling, and 5 donuts without filling.
All right. The probability that a donut with strawberry or blueberry filling will be chosen. Well, how many have strawberry or blueberry filling, Michael?
6.
6 out of 12. Of course, that easily reduces to
1/2.
1 to 2, which if we were to make that a percent class, what's 1/2? 0.5 or percent? 50%, right? So anytime you see 50% off, that's half off, right? Blueberry with, or donut with blueberry filling or without filling will be chosen. And what are the odds there, Kendall?
7 to 12.
7 to 12, which of course that doesn't reduce. We could make it a decimal, or a percent if we wanted to. I don't. And then donut with chocolate or fruit filling. Chocolate filling or fruit filling will be chosen. And what are the odds there, Audrey?
7 to 12.
Also 7 to 12. How many have those answers? On number 34. All right, so far so good. Questions? All right, turning the page. Alani? Let's go with Alani. Alani has to choose several objects off a desk. Why? We don't know. On the desk, there is a laptop. Maybe it's like a scavenger hunt. Grab one thing. On the desk, there is a laptop, tablet, cell phone, 3 textbooks, 2 Bibles, 5 pencils, and a pen. What's the first thing we have to do here, Brandon? Something they didn't do for us like they did on the last 2 problems. We got to figure out how many total possibilities exist on that desktop. How many total things are there?
14.
There are 14 things on the desk. So the probability of, now listen, a cell phone or an electronic device. Well, how many cell phones, Brandon? 1 out of 14. How many electronic devices? 3 electronic devices. But is a cell phone not an electronic device, class? Do you see that cell phone and electronic device are not mutually exclusive? Cell phone is technically already included in the 3 to 14. So mathematically, the proper way to do it would be to say, well, there's 1 to 14 chance of cell phone, 3 to 14 chance of electronic device, but subtract the fact that a cell phone is electronic, and we come up with, class, a 3 to 14 chance. Or practically speaking, cell phone or electronic device, that's stupid. I'll just look for electronic device. And you'll get the answer that way as well. All right, questions on that? How many had the 3 to 14 either way? All right, questions. All right, either a pen or a writing utensil. Again, you could say, well, how many pens, class? 1 out of 14. How many writing utensils? 6 out of 14. But isn't a pen a writing utensil? So since the 1 pen is also a writing utensil, once again we subtract that overlap because that's not mutually exclusive, and we come up with 6 to 14 or reduced Genesis. 3 to 7. There we go, a 3 to 7 chance. Or again, you just say pen or writing utensil. Well, that's stupid. A pen is a writing utensil, so forget that. I'll just look for writing utensils. 6 of them. And you end up getting 6 to 14 or 3 to 7. How many had that on letter B, regardless of which way you approached it? Again, if you see they're not mutually exclusive, a lot of times you can account for it up front. Bible or book will be chosen. Well, how many Bibles, class? 2 out of 14. How many books are there? There are 5 books. But obviously, class, a Bible is a book. So the 2 out of 14 is the overlap. We just subtract it right back again, or right up front account for the fact that, well, a Bible's already a book, and we just get, class, 5 to 14. So they gave us several examples that were not mutually exclusive. Now, to be fair, not all of your non-mutually exclusive will be that stupid easy. These ones were. But questions on number 36 with some overlap. Yeah, kind of poorly done, in my opinion, but whatever. I don't feel like rewriting their textbook for them. All right, number 38. Austin gets to pick a pet. We were at the thing like that yesterday, and they're trying to give away animals and stuff. Yeah, the doggy was really cute. The fact that it's going to be 200 pounds, not so cute in the future, but really cute right now, and soft. Anyway, Austin gets to pick a pet. Pet store has 5 birds, 4 cats, 7 dogs, and for you, Michael, 2 snakes. What is the probability that a mammal or a cat will be chosen? Again, I think the easiest way here is to be like, well, a mammal is a cat. So let's just find the mammals. Sound good? How many mammals are there, class? 11. But we also had to figure out how many total animals are available to pick from, class. 18. So an 11 to 18 chance that a mammal or a cat is chosen. How many had that for number 38, part A? All right, questions?
I have no idea what I did.
What did you have for your answer?
13 over 18.
13 out of 18.
Maybe I thought snakes were mammals.
What are snakes?
Reptiles.
Reptiles, good. What are birds?
Birds.
Birds. Good, see? I hear it's been years since biology class. He still knows this stuff. That's good. All right. A bird or an animal with legs will be chosen. Well, two things. First, a bird is an animal with legs. Second of all, here's another way to think of it. The only animal on the list without legs, assuming that one of the birds was not a chicken, and we've already obtained chicken legs, okay? Chicken, drumsticks. Anyway, assuming these animals are whole and entire, really we're just saying, what's the odds we don't get a snake? Well, how many snakes? 2 out of 18, right? So really what we're finding is the complement of a snake, meaning not snake, which would be class 16 to 18, which reduces to 8 to 9. An 8 to 9 chance. That is a ratio, not as a fraction, right? 8 9 to be a fraction, 8 to 9 the ratio, but 8 to 9 chance that it is a bird or an animal with legs. Yes, sir.
So did you find the complement of the answer and then find the complement of the answer that you just got?
No. It didn't want snake. It didn't want snake. So I'm saying, what's the odds of not snake? So we found what we didn't want and found the complement to get the answer. So there's a number of ways to approach it.
Okay.
Yep, good question. A dog or an animal with legs? Well, that's going to be the same thing, right? Because again, they're not mutually, they did a really poor job in constructing these. But once again, it's going to be animal with legs, which is 16 out of 18 animals, which is an 8 to 9 chance. How many have that, again, for part C? All right, Maddie, questions? Michael, questions? Use homework pass, okay. So that's why. Michael, questions?
I don't know what I did.
Does it make sense now that we're going over it? Because we really didn't get a chance to do a lot with this, admittedly, in our last lesson. Not like I was planning to do, so.
I think I was falling asleep when I did all these because my first 2 were wrong and 36 was the only one that I've gotten right so far.
Okay, all right. This one, number 40, is actually, I think, a somewhat legitimate way to approach this whole mutually exclusive thing. They finally did a decent problem. Read it for us if you would, Kendall.
Individual sports features we use on the school yearbook have the boys soccer team and 18 members, the girls volleyball team have 12 members, the golf team have 5 boys and 3 girls by 7.
All right. So we're trying to find the probability that a particular picture ends up being chosen for the yearbook cover. How many would like your picture on the yearbook cover? How many think that would not sell a lot of yearbooks? Why do you think we pre-order? Yeah. So they don't know whose picture's on. Anyway. All right. So a photograph of a girl or golf team member. All right. How many total girls are possible going to be chosen, class? How many girls are there? 15. 12 from the volleyball team, 3 from the golf team. So that's 15 girls out of, well, how many total people are mentioned here? 38. So 15 out of 38 chance of girl. Plus, what's the probability of golf team? Well, how many people are on the golf team, class? 8. So 8 out of 38. But there are girls on the golf team that have gotten counted twice. So we need to subtract the overlap. Girls who also play golf for the school class. 3 out of the 38 possible people. And we work it through this way, we end up getting 20 out of 38 reduces down to get 10 to 19, 5 by 2. Again, calculator does the reducing for you if you wanted to. Questions on that? How many had 10 to 19? Or 20 to 38 maybe just didn't reduce? Questions? Michael, the next one. Letter B.
Oh, you want me to read it? Okay.
Yeah, read it.
A photograph of a boy or a member of the volleyball team is chosen.
Is there any overlap between boys and members of the volleyball team?
No.
No. So in this case, we've really got it wide open. How many boys' sports pictures could there be, Michael?
23.
23 out of the 38. That's boy. And then how many volleyball people?
12.
12 out of 38. That's volleyball. And since there is no overlap, we get to just straight up add these, and we get
35 of the 38.
35 to 38. That does not reduce. We'll leave it just like that. How many had that for part B? All right. And then letter C. Maddie, read that one for us. All right. Now, I suppose it's possible that the golf team and the soccer team have people who play on both, but it doesn't tell us there are. So let's assume they are separate. So therefore, if you're a member of the soccer team, you're not a member of the golf team. So these are mutually exclusive again. We don't need to worry about subtracting anything. We're just going to add soccer team and golf team. And we end up with 26 to 38, which she already reduced because she's smart like that, to get 13 to 19. Questions on the homework? Do we feel like, no matter you had the homework pass, didn't need to do it, Michael had some issues falling asleep while you were doing it. Do you feel like you understand it now? Feel like it makes more sense now that we've had a chance to work? Let's do a handout. If you're watching on YouTube, this handout is in the description of the video. You can set your books aside for just a few moments. And let's do some more practice with probability. And then we'll get back into your textbooks as time permits. Yeah, you can write directly on here, that's fine. If you choose not to, I'll take it back from you later, but you don't have to not write on it. The first set of problems, very straightforward. They've given you lists of probabilities. They've written them as decimals rather than as percents or as ratios. The question is that a valid group of probabilities or not? What would make an invalid group of probabilities? Class?
Less than 0.
A number less than 0, number greater than 1, or if they don't add up to 1. So check A through D on that very first problem. See which of those are. Just put a check mark if they're good and cross them out if they're not good. If that's a valid list of probabilities, check mark. If it's not a valid list of probabilities, put an X through it. Just doing that first problem, A through D. Just the first one, A through D. All right, that's it. I feel like we should be done by now. We are. All right, we've gone on to the next one. Letter A. Are we good or not good, class? What's the consensus? Yeah, all of them are between 0 and 1. They all add up to exactly 1. Next one, class. Also good to go. They all add up to exactly 1. Nothing between 0 and 1, or nothing outside the realm of 0 and 1. What about letter C? No, they don't add up to exactly 1. So each probability individually looks like it would be okay. That group of probabilities is not valid. And the last set? Also no. The first two add up to the 1, and the last one's already too much. So yes, yes, no, no on A through D for the first one. How many had those? All right, any questions on those? Using the fraction button on your calculator, go ahead and hit the next problem, A through D. Using the fraction feature of your calculator, do the next one, A through D. Pencil down when you're finished. Letter A, what's the verdict, Genesis?
Yes.
That added up to exactly 1 on the first set? I did not get exactly 1. I may have typed it wrong. Anyone else get it added up to exactly 1? I got slightly off. I was like 23/24 or something when I added them.
I typed something and typed something wrong.
Gotcha. Okay. So yeah, number 1 should be a no for redemption, Genesis, letter B.
No.
Now, I actually got those adding up. Anyone else have them add up to exactly 1? I did have them adding up to exactly 1 on letter B. So maybe be careful as we enter. Maybe trying to go too fast. That's a possibility. So she's double checking. What about letter C? Let's go to Abby.
No.
No, they didn't add up to exactly 1. And letter D, should we have even typed them in? No, because as soon as you see a 9 out of 8 chance, you're like, no, never mind, forget that. And we move on. So I got a no, yes, no, no for A through D. How many had those correct? All right, questions. Genesis.
It was like typing kind of too fast.
Okay, all right, so just be careful with those. Let's move on to the next problem. Read all the way through part A for us, if you would, Brandon. Read the next problem through part A.
Okay. A jar contains 10 wooden balls, 3 red, 2 white, and 5 green. One ball will be drawn from the jar. The ball is red.
All right, what is the probability the ball is red, Brandon?
3 to 10.
3 to 10, because there are 3 red balls out of 10 total. Letter B, the ball is green, Audrey. 5 to 10, which is 1 to 2 is the proper way to read it, but on a test you're just writing it anyway, so if you write a half, you're not wrong. What about the ball being white? Abby?
1/5.
1 to 5 is how we would say that, or 2 out of 10, it reduces down to 1 to 5. Then on letter D, by the way, any questions A through C? Everyone understand A through C? Really straightforward. Then we get to letter D. The ball is either red or green. Genesis? 8 to 10, which we could reduce to get 4 to 5. Very good and said properly. Thank you. Letter E. The ball is either red or white. Maddie? 5 to 10, or reduce it 1 to 2. The ball is either green or white. Michael?
7 to
7 to 10, and it doesn't reduce. The ball is either red, green, or white. Kendall?
1.
1. It's absolutely certain. You're like, man, I really hope I get a red, white, or green one. Happiness, you're going to get your wish, right? And then letter H class, the ball is orange? 0. You're not, unless of course it's an illusionist who's got an orange one up his sleeve, and as he reaches and he drops it down out of his sleeve, hey, I got an orange one. There wasn't even one in there. Amazing. And anyway, but I digress. How many like watching illusionist magic tricks, magicians? You're like, I like watching it. I always try to figure out how it's done. I can never figure it out, you know. Anyway, if I'd study it, I'd probably figure it out, and then it wouldn't be fun anymore, but I like it. Anyway, questions on that set of problems. Let's go to the next set of problems, and here's where things are going to get a little bit more interesting, and we have those numbered balls as we'd seen once before. Read that problem all the way through part A for us, Michael.
A container contains 3 red wooden balls numbered 1 through 3, 2 white wooden balls numbered 1 through 2, and 5 green wooden balls numbered 1 through 5. A single ball is removed from the container. The ball is either red or has the number 4.
Well, what's the probability, first of all, of a red ball, class? 3 out of 10. There's 10 total balls, right? Still 3 red, 2 white, 5 green. So it's basically the same problem as last time, except we numbered them this time. Do you see it? So 3 to 10 is for red. What about the number 4? How many 4 balls are there, class? Only 1 out of 10. Is the 4 ball a red one? So we would say that these two things, red and 4, class, are mutually exclusive. Good, Genesis. And so our probability, class, 4 to 10, which becomes 2 to 5. 2 to 5. The next one says the probability of the ball is either white or has the number 5. By the way we'd see this would be P white or 5. Right? We'd see these two things. This is your probability notation. Well, what is the probability of a white ball being selected, Audrey? 2 to 10. And then the number 5 ball would be how many 5 balls in there, Audrey? 1 out of 10. And is the 5 ball a white ball? No. So they're mutually exclusive again. Our answer this time, class, 3 to 10. Questions on this one? Still making sense to you? All right, look at the next one. The ball's red or has the number 3. Well, again, probability of red or 3. How many red balls, class? 3 out of 10. How many 3 balls do we have? 2. We have 2 3 balls. But are any of the 3 balls red? Yes. One of them, the red 3. So what do we have to do? Subtract how many? Just the one single ball that is both red and 3 at the same time. Does that make sense? And so we end up with 4 to 10, which reduces to 2 to 5. Questions on the overlap. I feel like this is more of a true overlap type problem, more so than some of the others where It was so stupidly obvious. This takes a little bit more thought. This is more like what you would see on quizzes and tests. Questions? All right, take a look at letter D. The ball is either green or has the number 3. So green or 3. Well, what's the probability of a green ball? Kendall?
5.
5 to 10. And then what's the probability of a 3 ball, class? Still 2 to 10, right? Like it was before. But are there any green 3s, class? How many green 3s? A single green 3 that we need to subtract away, and so we get 6 to 10, which reduces to 3 to 5. Are you keeping up with me? All right, any questions? Do the next one, letter E. The ball's red or has an odd number? The ball is red or has an odd number on it. Take a moment to think that one through. Start by finding the probability of red, then find out how many odd, and then subtract any that happen to be both red and odd. Looks like Maddie's got it. Maddie, how many red balls? 3 to 10. How many odd numbered balls? 6. 1 and 3 for red, 1 for white, 1, 3, 5 for green. So 6 out of 10 for odd. How many balls are red and odd? 2. The red 1 and the red 3. So we're going to subtract the 2 out of 10. And what's our probability of either getting a red ball or an odd numbered ball? 7 to 10. How many got 7 to 10? Okay, any questions on that? Do the next one, white or even? White or even? And Michael's got it. Michael, how many white?
2 out of 10.
How many even?
4 out of 10.
How many white balls are even?
1.
1, so we'll subtract that away to get
1/2.
5 to 10 or 1 to 2. How many have the 1 to 2? All right, questions? Feel like we're getting the hang of it? The next one's really fun, and I'm really glad they gave us a picture, because otherwise this would be really, really annoying. You might want to label on the picture here. See how you have a picture of a red and white pencil? Put a little 10 next to it, because there's 10 like that. Then red and green, there's 20. There are 15 that are red and blue, and there are 30 white and blue. All right, so it might help to have those numbers right there. What is the probability that the pen has either white on it or blue on it? Well, how many of the pens have white on them, class?
40.
How many?
40.
40, because we've got 10 of the first ones here, and we've got 30 of the next one. So that's 40 out of, how many total?
75.
75. So 40 out of 75 have white. All right, then how many have blue is the next one, class?
57.
How many have blue?
45.
45. She's got 15 of the red and blue and 30 of the white or blue, right? Did you label them correctly? 10, 20, 15, 30 in that order. So we should have, you said 45 out of 75 have blue on them. But you realize we've double counted some pencils, haven't we? Some of the pencils are both white and blue at the same time. How many pencils are white and blue?
30.
The 30 at the tail end. So we'll subtract those away. So how many pencils have either blue or white on them somewhere? Which reduces down to 11 to 15. Questions on that one? A little bit different, right? The next one has either red or blue. Well, how many have red, class? 45. The first three kinds on the picture, right? 45 out of 75 have red. How many have blue?
45.
Another 45 to 75. By the way, you can tell you can't get this for your answer, right? 90 to 75? That's impossible. Because how many are both red and blue? 15. So we subtract the 15 to 75, and what do we get? 1. 75 out of 75. In other words, every single pencil has, or pen, no, those are pens, not pencils. I thought they were mechanical pencils. How about that? All right, pens, sorry. All the pens have either red or blue on them somewhere. So you got a 100% chance of being happy. I hope I get one with red or blue on it. You're going to be a happy person. No red or no green. Well, how many don't have any red, class? The last color, right? The 30 out of 75. How many have no green? I got 55 as well. 10, 15, and 30. So 55 out of 75. How many don't have any red or green on them anywhere? The last pen as 30 plus you out of 75 gives us 55 to 75, which once again, 11 to 15 like it was a minute ago. That's a 11 to 15. It just doesn't look like a 15. It looks like a strange backwards T. All right, that's a 5. All right, questions on that? Do letter D. No white or no green. No white or no green. Bless you. She's allergic to probability problems. What are the odds I'd get a student in my class that's allergic to? She starts breaking out into hives at the question. All right, probability of no white, class. 35 to 75. Probability of no green. What is it? I got 55 to 75. But how many pens have no white or no green on them? The red and blue ones, which are 15 to 75. And we end up getting here either no white or no green. Something's wrong.
I think it's just 15 over 75 because every other pin.
Yeah, so it's either no white, which should be 35 to 75, or no green.
Maybe you should do negative 35 or something.
I'm like something right. My thought was this: the only one as I'm looking at the picture that doesn't have white or doesn't have green. I guess technically we have to do complement of having white. That's what it is. Complement of having white, complement of having green. Yeah. Anyway, I look at the picture. The only kind of pen that doesn't have white or green is the red and blue ones, and that's 15 of them. So that was going to be the easy way I was going to point out afterward. Let's just roll with the easy way and forget the hard way. But now I'm curious. Complement of white. Complement of white is 35. Well, white itself is, yeah, that'd still be it though, right? And then green, complement of green. Anyway, no white or no green, because double negative. Neither red nor green, no red or green. That should be pretty easy. Which pen is the only kind that doesn't have red or green, class?
30.
The blue and white, which is 30 to 75, what is that, 6 to 50, or no?
6 to 25. 2 to 5.
2 to 5. 2 to 5. When you reduce all the way, no white or green. No white or green. That's the 15. Oh, gotcha. I was right the first time. This is correct. There's a guaranteed chance that the pen you get will either have no white or it'll have no green. Because no pen had both green and white. We were right the first time on letter D. It is a 1-to-1 chance of no white or no green. I was second guessing. I was reading it like letter F. Neither white nor green. But no white or no green. Every pen has no white or no green. I just hate both colors. All right, well, guaranteed one of them won't be on there. All right, and then letter F, neither white nor green is slightly different than letter D. That's the red and blue, and that's the 15 to 75 or 1 to 5. Questions on these? All right, if you didn't write on them, I'll collect them back. If you did, just keep it. And look back in your books now, page 502. Make that page, yeah, page 502. And we are running low on time here. Let's look at complementary probabilities now. Look at complementary probabilities now. And number 22 tells us the probability of some event happening, probability of A, is 0.312. They want us to find the complement of A. Well, how do I find a complement, class? Subtract from 1. So, as you see, it's 1 minus 0.312. And what do we get? 0.688. They gave it to us as a decimal. I'll leave it as a decimal. Look at number 24. In the history of a given school, 3,002 of the 12,044 graduates graduated with honors. If the event is the probability the student will graduate with honors, what's the complement? What does that mean? What's the odds that a student does not graduate with honors? Well, easy way to find this. How many didn't graduate with honors, class?
9,442.
9,442. Just subtract from the total, and you can divide that by 1244 or 12,444, or you go ahead and divide the 3,002 by the 12,444, and what would that be? So I'm going to divide it real quick. 3,002 divided by 1244. These are honors people. These are smart Alex.
0.241.
0.241. All right, so then no honors would be 1 minus that. So subtract that decimal from 1. Or, you see on the button at the bottom of the calculator is positive, negative? If you've got a 0.214 or 241 on your screen already, if you hit the negative and then add 1, that's another way to subtract from 1. And what do you get? 0.759. The other way is, if 3,002 did get honors, as Michael said, 4,442 didn't. So divide that by the 12,444 total, and that's another way to get the 0.759 for your answer. Number 26, stay with me. Catherine's won 12 and lost 18 of the tennis tournaments she entered last year. If the probability is that she'll win a tennis tournament, what's the complement? Well, what's the complement of winning? What's the complement of winning? Losing. So basically, just find the probability she loses. How many did she lose? How many did she lose? 18 out of how many total? 30. So what is that? 0.6. 18 out of 30 is a 3 to 5 chance she loses, or you could say a 0.6, or a 60% chance of failure, losing. And anyway, homework for this evening. I want you to do page 502 to 504, page 502 to 504, 502 to 504, numbers 15 to 39, the odd. 502 to 504, 15 to 39, the odd. And we'll take a look at all of this in our next lesson. Have a wonderful rest of your day, and you are dismissed.